Good day everyone, my name is Graphics. Today we want to study an aspect of mathematics which is called permutation and combination, but today we're looking at the application of this. In my previous video I said permutation means the arrangement, while combination is all about selection, right? And I said earlier that in my permutation order matters. That is, the way it is arranged matters. I would say that my 1 and 2 is one order, my 2 and 1 is another order. So if I'm asking how many ways can you permutate 1 and 2, we say is what? It's 2 ways, because either it is 1 2 or it is 2 1. So that will be what? 2 factorial. That is 2 ways, right? Now, but in combination, it's all about selection. If I say how many ways can 1 and 2 be selected, right? It is just 1, because it's the same figure we have there. We don't really change it. So we say my general formula for permutation is that when we have n permutation r, it is going to give us our n factorial all over n minus r factorial. While in combination, we say that when we have my n combination r, it will give me my n factorial all over n minus r factorial. So this is what we have. This is combination, permutation, and this is what combination. I've done examples on this, but today we want to look at the application of this. Now, for instance, we might be told, in how many ways can the word committee, or can the word ellipse, or can the word laptop be arranged, right? Now, one thing you need to know is that there are some letters, there are some words that are repeated, and there are some that are not repeated. But now I'm talking about distinct objects. Let's look at what? Distinct objects. Distinct objects. So now, if you look at these distinct objects, for instance, I talk about the word graphics. If I'm told in how many ways can the word graphics be arranged, right? Now, if you look at this word now, we have letter G there once, we have the arrow there once, we have A here once, we have P, H, I, and X are all once here. They are not repeated. So it means that what? The word that forms this letter graphics is what? Is distinct. So in how many ways can this be permutated? Means how many ways can this be arranged? We have 1, 2, 3, 4, 5, 6, 7. That means that what? It can be arranged in what? 7 factorial, right? Which means that what? 7 permutation 7. And 7 permutation 7 means that what? 7 factorial all over what? 7 minus 7 factorial, and we have what? 7 minus 7 factorial, sorry, right? And at the end of the day, we'll still be having 7 factorial all over. 7 minus 7 is 0, and this will be 0 factorial. And we know 0 factorial and 1 factorial is 1, so we'll still be having 7 factorial all over 1, which is saying 7 factorial. And 7 factorial will give us 5040. So that will be 5040 ways that the word graphics can be arranged, right? Now, the key word here is this. This is without restriction. Whenever you are looking for the amount of ways an object can be arranged, and without any condition, we say without any restriction, is 7 factorial. Now let's take one other example. Now, what about the word climb? I have the word climb, right? The word climb. Now it is distinct, no repetition. So, and that will give us what? 1, 2, 3, 4, 5, right? That will be 5 factorial. which is we are saying 5 permutation 5. So our answer is what? 120 ways. So that's how many ways the word climb, and this is without restriction. Now let's go to another category. What about when there is restriction, when there is a condition? So let's see how this will go. Now look at this. It says, in how many ways can the word graphics be arranged such that Roman figure 1, no restriction. Roman figure 2, GRA must not be together. GRA must be together, and Roman figure 3, GRA must not be together. So what we should do here is, for no restriction, solution. The solution we have here, Roman figure 1, for no restriction, we say we've done it earlier. We have the word GRA, PHIX. For no restriction, and there are no, you check, are they repeated? No. How many are the alphabet we have there? 7. So that will be 7 factorial. And that will give us what? 5,040 ways. Can the graphic be arranged without no restriction? It's just 5,040. Then Roman figure 2. We are told that GRA must be together. So if I have the word graphics, right? It says this GRA must be together, and I'm separating it from what? The fixed that is there. Now if you look at this, 1, 2, 3. Inside the brackets, together, there are 3 distinct objects, and we call it 3 factorial. Then everything all together, these 3 together is giving us 1. So this is 2, 3, 4, and 5. So we're having 5 factorial. So we're multiplying both of them together. So 3 factorial means 3 times 2 times 1, which is what? 6. 5 factorial means 5 times 4 times 3 times 2 times 1, which is what? 120. So 6 times 120 is going to give us 720. So this will give us 720 ways. So if GRA is together, so the amount of way it can be arranged when you bring these 3 together, whenever they move together, it is what? 720 ways. Now let's look for the third one. It says GRA must not be together. So they must not be together no matter what. They must not be together. So we say that the third one here will be GRA must not be together. So for must not be together, will be equals to no restriction, right, minus must be together. Is that taken? No restriction minus what? Must be together. So when you do that, for no restriction we have what? 5,040 minus must be together, we have what? 720. So 5,040 minus 720 will give us, that'll give us 320 ways. So this is how it goes. This is how you go. And sometimes you might just be given straight that in how many ways can the word graphics be arranged such that GRA must not be together. For you to get must not be together, right, you must have no restriction and must be together, because this is the formula for it. So this is about distinct objects. Now let's talk about repeated objects. Now for repeated objects, for instance, now if I talk about the word committee, we have COMMITTEE, and we are told in how many ways can the word committee be arranged. First of all, you check, is there any repeated word there? Yes, there's a repeated alphabet there. So that means we are going to say, okay, for A, solution here. For C, we have 1. For O, just 1 word. But for M, our M is equals to what? 2. The T here is equals to 2, and the E also is equals to 2, right? Then the total words is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. That will be what? 9. So therefore, we will say that the number of ways this can be arranged is that what? The total words, right, all over what? The total object over what? Repeated object. Repeated what? Object. So what is the total word here? Total object here, we have 9. So I'll say 9 factorial all over the repeated. That will be 2 factorial times 2 factorial times 2 factorial. And this will give us 9 factorial is 3, 6, 2, 8, 8, 0 all over what? 2 factorial is 2, so 2 in 3 places, that is what? 8. So divided by 8, so we are having our value to be equals to 4,5,360 ways. So this is what we have. 4,5,360 ways. That is how this can be arranged. And mind you, this is no restriction. There is no condition here. Right? Now, what about when we have the word crosses? You might say, in how many ways can the word crosses be arranged? Right? Without restriction, we know we have x3 here. So for solution here, without restriction, my x is the only one that's repeated, and we have 3. So we know that the number of ways can be arranged is total words, which is we have the therefore we say that the total words, total objects all over what? Repeated object. Repeated what? Object. And this will give us total object here is 1, 2, 3, 4, 5, 6, 7. That is 7 factorial all over the repeated, and that is just one of them, and that is what? 3 factorial, right? So the 7 factorial is going to be giving me 5,040 all over 3 factorial is 6. So 5,040 divided by 6 is 840. So this will give me 840 ways. That is without restriction. Now let's take a good example. Now if you look at this now, it says, in how many ways can the word committee be arranged such that TTEE must be together and COMM must not be together? So what you do is this. First thing and foremost, what you do is, first of all, calculate for no restriction. So when you say for no restriction, we've already calculated for it, and we are having 45,360. So for no restriction, just write calculating for what? No restriction. Even though when it is not given, you have to calculate for it. No restriction. Right? I will say the word committee. So it's giving us what? 7 factorial. That is it's giving us 45,360 ways. That is what we calculated here. For the word committee without no restriction, we have this. Right? Now we'll move backward. For no restriction, now you say TTE must be together. So when you say TTE must be together, so if we have T, T, E, E, must be together, right? So we're going to write it. We have COMMI, and they say TTEE must be together, right? So these two are together. Now when you count what is inside there, we have 1, 2, 3, 4. We have 4 objects here, but funny enough, the objects are repeated. We have 2e, so divided by 2 factorial, and we have another 2t. We have what? 2 factorial. That is what you're having. Now all these 4 objects calculated as 1. So this is 1, 2, 3, 4, 5, 6. So we have total of what? 6 factorial, right? All over this repeated object also, and that will be what? 2 factorial. So from here we are going to say that 6 factorial means that 26 factorial means 720 divided by 2 multiplied by 24 divided by what? 4, because 2 factorial is 2, 2 times 2 is 4. 720 divided by 2 give us 360. So we're having 360 multiplied by 12. 4 divided by 24, that will be 6. That will be 6 times 360. So this is 6 multiplied by 360. That is, my answer will give me 2160 ways. 2160 ways. That is, if TTEE must be together. Now, if you look at this also, we say COOM must not be together. First of all, we know that COM must not be together. If you're calculating for COM must not be together, it means that what? COMM must be together. So this is what we have here. For you to calculate COMM must not be together, we have to calculate COMM must be together. So let me just do it here. For COMM must be together. You know, we are not taught to calculate it, but for you to get must not be together, you must be together. COMM must be together, right? It will be, we have COMM, right? And we also have into brackets this way, and we have ITTEE. Now if you look at this, inside there we have how many? 4 factorial, but it's repeated 2, so all over 2 factorial multiplied by all this here is 1, 2, 3, 4, 5, 6. This will be what? 6 factorial. All over we have 2t and we have 2e, right? So the total over the repeated. So 4 factorial is 24. 24 divided by 2 is 12. Multiplied by 6 factorial is 720. 720 divided by 4 will be, we have 720 divided by 4, and that will be 180 times 12. So we have 180, 12 times 180, and that will give us 2160. Also 2160, right? So this is COM must be together. So for us to calculate must not be together, for must not be together, COMM must not be together, right? It will be must be together. It will be no restriction, right? Minus must be together, must be together. So what are no restriction? No restriction here is what we calculate earlier, which is 45,360 minus must be together, which is 2160 minus 45 360. So we have 43,200. So my answer here will give me 43,200 ways. So that is my answer, right? So this is how you calculate permutation of repeated objects and when condition is given. Now we'll go into combination and see how we can do that. Now, the example goes this way. It says, in a class of 7 Muslims and 15 Christians, a committee of 3 Muslims and 8 Christians is to be formed. In how many ways can this be done? If A, there is no restriction, B, one particular Christian must be included, and C, 2 particular Muslims must not be included. So what you have to do, you need to draw your table. We have 2 of them. The first one we have here, the total, you look for the total amount of Muslims and total amount of Christians that should be up. So if you look up, the bigger amount here, 15 Christians, I have 15 Christians, right? I use C for my Christians. And the bigger amount of Muslims is 7, and we have 7 Muslims, which occupy the top position here, then followed by the rest. And we have 7 Muslims, we have 8 Christians, the other one will be 8 Christians, right? And the next one here we have 3 Muslims. So this is what we're having. So the Muslims must be under the Muslims and the Christians must be under the Christians. So if you look at this now, here we say these are the religion here. So you say in a class of 7 Muslims and so we have 2 religion. So we have, here is the religion, right? And here is the committee. So if I put this in the table this way, I'll be having something like this. So this is what I have here. Now doing this way, it says in how many, when there's no restriction, you are going to write that the total amount of Christians here is 15 and 8 is to be selected from 15. So since you're selecting 8, the word selection, we're selecting, right? 8 from 15, so we're having 15 combination 8 multiplied by 7 combination 3, because we're selecting 3 from 7. Doesn't matter whether it's the first or the last, but we're selecting 3 people. And for here we have 15 from 8. So from our formula, we say that my 15 factorial all over what? 15 minus 8 factorial, 8 factorial, multiplied by 7 factorial all over 7 minus 3 factorial, 3 factorial. So when you do that, you're going to be having this 15 will be 15 factorial all over 15 minus 8 is 7, right? Factorial, then we have 8 factorial multiplied by 7 factorial all over 7 minus 3 is 4 factorial over what? 3 factorial, right? So if I move 15 to 8, this will give me 15 multiplied by 14 multiplied by 13 multiplied by 12 multiplied by 11 multiplied by 10 multiplied by 9 multiplied by 8 factorial, all divided by what? 7 factorial, 8 factorial, multiplied by 7 times 6 times 5 times 4 factorial all over what? 4 factorial, 3 factorial. I'm stopping at 4 because I have 4 here. I'm stopping at 8 because I have 8 here. So 8 factorial equate 8 factorial, 4 factorial equate 4 factorial. We're left with 7 factorial, right? So and this 7 factorial can be written as saying this will give me 15 this will be 15 multiplied by 14 multiplied by 13 multiplied by 12 multiplied by 11 multiplied by 10 multiplied by 9, all divided by 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Multiplied by, we have 7 times 6 times 5 all over 3 times 2 times 1. That's mean of 3 factorial. Now if you look at this 3 will, in 6 is what? 2. This 2 will equate this 2. We are left with what? 5 and 7. So 7 times 5 is what? 35. Now we have 2 in here 1. We in 10 will give you 5. This 5 will equate this 5. Right? We say 4 in here 1. In 12 is 3. This 3 will equate this 3. We also say the next one, 7 in here 1. In 14 is what? 2. 2 will equate 2 in 6 is what? 3. Right? 3 in here 1. In 9, that will give us what? 3. So we are left with 15 times 13 times 11 times 3. So that will give you 6435. 6435 multiplied by 35. And that will give us 225 ways. That is for no restriction. Now the next condition here that we have is that it says one particular Christian must be included. So if one particular Christian must be included, we are going to do this. It says number B, one particular Christian, right, must be included. So you just rewrite this again, which is 15 combination 8, 7 combination 3. So we have 15 combination 8 multiplied by 7 combination 3. So for this, for the Christians, this is for the Christians, Abi, and they say one particular Christian must be included. If from the word must be included, and this for the Christian, means you're subtracting 1, since this one must be included from up and from down. So this will now give us 14 combination 7 multiplied by 7 combination 3. Now if you solve that using your combination, this is going to give us 14 factorial all over 14 minus 7 factorial 7 factorial times 7 factorial all over 7 minus 3 factorial 3 factorial. In the long run, if you do the way I did the initial one here, we are going to be having 120 ways, right? Then for the third one here, it says 2 particular Muslim cannot be there. So you are going to rewrite this. Let's assume this is it here now. If 2 particular Muslims will not be there, you are going to write 15 combination 8 multiplied by 7 combination 3. And this is for Muslims, right? And when they say must not be there, that means you only subtract from only the top here, the total object, which is the top. So must not be there, you subtract from only the top. Must be there, it will subtract from both the top, from the total object and selected object. So from here, we're going to be having 15 combination 8 multiplied by 5 combination 3, and this will now give us 15 factorial all over 15 minus 8 factorial 8 factorial multiplied by 5 factorial all over 5 minus 3 factorial 3 factorial. So in the long run, we are going to be having 63450 63450 ways. when you do it the way I did the initial one. So if this video was helpful, don't forget to click on the subscribe button. Thanks for watching.